Hey guys, welcome back. My name is Roland and I'm your tutor. In this particular video we'll be doing triangles and we'll be discussing the different types of triangles and how one deals with them in Euclidean geometry. So as we know, a triangle is a three-sided polygon. We get three different types, the first of which is the equilateral triangle, and by the name itself we can easily state that all sides will be equal. If all sides are equal, that means all angles are equal. We then have the isosceles triangle, where you have two equal sides and two equal angles as a result of that. Thirdly, we have the scalene triangle. The scalene triangle has no equal sides and no equal angles. There we go. So we've got the blue, the green, and the yellow. So let's move forward and draw these guys so you can see how they look. So the equal sides for the equilateral triangle look as follows. They're all the same length, they have all the same angles, and they're always going to be 60 degrees. Why do I say this? Well, in a triangle, all of the internal angles are actually supplementary. Supplementary means they sum to 180 degrees when you add them together. You then have the isosceles triangle, where you have two equal sides, and the angles at the bottom left and the bottom right in this particular diagram are equal. So at the point B and the point C, these two angles will actually be equal. In the equilateral, the angle A, B, and C will also all be equal to each other. Now if we try and draw a scalene, it's a little bit more difficult. We have A, B, and C. None of the sides are equal and none of the angles are actually equal. Next we have the acute triangle, and the acute triangle is a triangle where all internal angles are less than 90 degrees. And any triangle or any angle that is less than 90 degrees is labeled an acute angle. So an acute triangle is a triangle where all interior angles are less than 90 degrees, as mentioned. So this is nicely noted over here. Next we have the obtuse triangle. In this particular triangle, as I'm sure you can guess, there needs to be at least one obtuse angle. As you can see, I'm writing it here. It's one interior angle that is obtuse, meaning it's greater than 90 degrees. The next is the right-angled triangle. We use these triangles when we do Pythagoras. So the right-angled triangle is a triangle that looks much like this, where you have one of the angles being 90 degrees, represented by a box. You then have the hypotenuse. You have angles A, B, C, and we will go further into this when we start doing trigonometry. So we say there's one interior angle that is 90 degrees. Easy game. There we go.